Have you ever played a game where you asked yes or no questions to figure out a word that was taped to your back? What you were really doing was finding out the properties of that object. Properties can help identify and classify substances. When you were asking, is it large, is it small, what color is it, stuff like that, those are physical properties. And a physical property is going to be a characteristic that can be observed, and you're not changing it into a new substance. So if you're identifying a tree, you'll say, it has green leaves, it has brown bark, you're talking about color. You also can talk about texture. So let's get into some examples of physical properties right now. You're going to make a list in your notes. Magnetism is a physical property. We're going to be doing a lab where we take iron and sulfur, and alone iron is magnetic. It has that property, and sulfur does not. So iron has magnetism as one of its properties, and it identifies it as iron. Conductivity is another physical property, whether or not it conducts electricity or even heat. For instance, styrofoam or paper, it doesn't conduct heat, and that's why Starbucks gives you, your coffee in a paper cup rather than a metal cup, because metal conducts. So that's a physical property. Phase of matter, what that means is it a solid, liquid, or gas? What phase is it in? Let's see, solubility is another physical property. That just means the ability to dissolve. Color is a physical property because you can change the color. You can dye an Easter egg or something like that, but it's still that original egg. So color is a physical property, but it also kind of goes into the chemical properties category as well. So color goes back and forth, but color can help you identify an object. My son and I play I Spy all the time right now, so he's actually working with physical properties. He doesn't even know it. So color is a physical property, helps you identify objects. Texture is also a physical property. Going back to the tree, when you feel the bark, if I had your eyes closed, blindfolded you, and gave you different objects, you can use texture as one of the physical properties to help you identify the substance. Freezing and melting, boiling points or melting points, those are all physical properties, because even if you have an object that boils, like if you have water in a pan and then it boils and it turns into a gas, it's still H2O, it's just in a different form, it's in a different state of matter. So that's a physical property. Density is kind of a keyword that we're going to be focusing on for a day or two, but it's a physical property. And density is going to be the amount of matter in a given amount of space. So you have this, your body is a given amount of space, and all the stuff that's packed into that space, that defines your density. It's the amount of matter in a given amount of space, and space is volume. So density is actually calculated mass over volume, mass over unit volume. So we're going to actually go into depth on density, but write down density is mass per unit volume, or the amount of matter in a given space. Size is also physical property. If we were, closing our eyes and playing the game, if I said that this is a really large object, that would cancel out all the little tiny things that might have been in your thoughts. So size is a physical property. And you could blow things up, like if I had a balloon and I changed the size by blowing air into it, it's still a balloon, so it's a physical property. You're not changing what's called identity of the object. Ductility is a new word I want you to write down. Ductility is the ability to draw into wires. So things that are ductile would be some of the metals, like copper is very ductile. Copper, you can draw it into thin wires, and that's why we like to use it for our electrical appliances. Or if you look at the cord for your computer, it's got this, coating on it, this rubber coating. It's an insulator, because underneath that, if you were to cut it open, you'd see copper wires. And copper conducts electricity, and you can also draw it into wires. So it's very ductile. So a lot of metals are like that. Nonmetals are not ductile, because most nonmetals are going to be gases at room temp. So malleability is the last word. This is the ability to pound into sheets. So what things would be malleable? Aluminum is very malleable. You can pound that into sheets. A lot of metals are malleable. Gold's malleable. We can make it into jewelry. Silver's malleable. Platinum's malleable. A lot of metals are malleable. Iron's malleable if you get it hot enough. So physical properties are going to help you identify matter. Each of these properties are going to be unique for that object. Physical changes do not form new substances. We're not going to create a new substance. They do not change the identity of the substance either. So here I have a couple of examples. When you're burning a candle, okay, your candle's getting smaller and smaller and smaller as it burns, but you're not creating a new substance as far as the wax goes. The wax is just melting, it's just changing shape. Shape is another physical property, you should add that to your list as well. Changing shape is just a physical change. It doesn't change the identity of the object. It's still wax as far as this candle goes. Same with the aluminum can. If I were to smash it with my foot or crush it, it's just a physical change. I'm just changing the shape, but I'm not changing what it is. It's still an aluminum can. As far as the bread goes, it's just a physical change. When I cut it, it's still bread. I'm changing the size of it, but just by cutting it, it's not changing it into a new substance. It's still bread. And with the butter, if I take butter and I put it in the microwave and I melt it, it's going from more of a solid form to a liquid form, and it's still butter. I didn't change the identity of it. I just changed the shape, and I changed the state of it because it went from solid to liquid. So write all these examples down. Chemical properties describe matter based on its ability to change into new matter that has totally different properties. So this is going to be different from physical properties that don't change the substance at all. Chemical properties are going to change the substance. The new substances have very different properties than they did before. For example, when wood is burned, ash and smoke are created. These new substances have very different properties than the original piece of wood had. A couple of examples of chemical properties would be flammability, obviously, the ability to burn. Ash and smoke can't burn, so they have the chemical property of non-flammability as opposed to the wood. Another example of a chemical property is reactivity. That's the ability of two or more substances to combine to form two or more new substances. An example would be reactivity with acid, like with acid rain, that tends to degrade the soil or degrade, even like cars and stuff. If you're dealing with like out in LA, they get more acid rain. If in the lab, I'll take hydrochloric acid and put it on different substances in the chemical hood, and you'll see that you'll have a reaction to that. And you can also get reactivity with oxygen. A lot of things start to rust as well if they're exposed to oxygen for too long. How can you tell a physical property from a chemical one? You could basically observe physical properties without changing the identity. A flower is, it's a flower because it's soft, the petals are soft, it might have a scent to it. Those are all physical properties. Even if you pulled off some of the leaves or petals, you're not really changing the identity of the flower. Chemical properties aren't as easy to observe. For example, you can't see that wood is flammable. Only after you burn it, then you can tell that it has a chemical property of flammability. It's important to know what the chemical properties of a substance is so that you could use the right materials. When you look at kids' pajamas, if you look at the tags, they use special substances now that are non-flammable, and that's important because in the middle of the night, if you have a kid in their pajamas and there's a house fire, you don't want their pajamas to catch on fire. So they use some materials that contain chemicals that are non-flammable, so hopefully that their pajamas won't catch on fire. Scientists really rely on these characteristic properties of different substances to identify and classify those substances. All right, chemical changes. So we had properties that ID a substance. Now, chemical changes happen when one or more substances are changed into new substances, and they have totally new and different properties. You can see that it's totally changed into something else. You can't tell what kind of chemical properties a substance has until it goes through a chemical change. For physical properties, you can tell. You can see its color, you can feel it for the texture, you can see its size, you can even check out its density, if it's heavy or if it floats, stuff like that. Those are physical properties. For chemical properties, you can't really tell if it's flammable, if it reacts with acid, stuff like that. If it produces light when a reaction happens, you can't tell any of that until it actually goes through the chemical change. You're not going to be able to reverse a chemical change. So an example would be like baking a cake. Signs that a chemical change is happening would be like a change in color. Also when you get like different odors that happen, like when milk goes sour, that's a chemical change. Let's see, production of heat. Anytime you see bubbles being produced, you know that a chemical change is happening. Sometimes you'll have a situation where sound or light's given off. We'll do a really cool experiment in January where we'll take a glow stick and we'll heat it up, and the chemicals in that glow stick will start reacting quicker, so a chemical change is happening, and they'll give off a really bright light. Thank you very much for watching, and I'll see you soon.